Good morning everyone. Myself Nageshwara, IIT Chemistry faculty. Today we are going to discuss about the next subtopic in matter in our surroundings. Already in the previous class we discussed about the introduction of the matter. What is meant by matter? What are the physical nature of the matter and characteristics of the particles of matter. In today's class, now we are going to discuss about how this matter exists in nature. How this matter exists in nature. Normally, matter exists in usually three states. Those are solid states, liquid state and gaseous state. Apart from this matter is also existing two other important state of matter. Those are plasma and Bose-Einstein. In this class, now we are going to discuss the properties of the all five states of matter. Let us discuss first of all let us compare each and every property of the solids, liquids and gases. The first one, how we can identify a solid state of matter, a liquid state of matter and gaseous state of matter. That means when you observe any solids, these are exist in definite shape and definite volume. Definite shape and volume means when you take any solid type of material, let us take this duster, it contains a fixed shape as well as it occupies a fixed amount of volume. That means solids are having definite shape and definite volume. But in the case of liquids, it is having definite volume but not shape. Because if you take 1 liter of water, put it in two different bottles, two different shapes of the bottles. Now here the volume of the water is same, that is 1 liter. That means volume doesn't change, but the shape of the water changes based on the container what you took. If you take two different shapes of the water bottles means the shape of that water is different for two different bottles. Likewise, we can say liquids are having definite volume but not shape. In the case of gases, it is neither definite shape nor definite volume, because gaseous particles doesn't have any shape. They can have different type of shapes, and at the same time when you observe the volume of the gases, just take one bottle of gas, then the volume of the gas is nothing but the volume of the water bottle. Just open the cap, then the same amount of gaseous particles occupy the whole room also. Means what we can say, gaseous particles doesn't have definite shape as well as definite volume. Let us discuss. The first property is nothing but density. Usually solids are more density. What is meant by density means mass per unit volume. Mass per unit volume. When you observe the density of the solids, it is more. In the case of liquids, it is somewhat less. But in the case of gases, it is very less. And the next one, interparticle distance. The next one, interparticle distance. when you observe the solids, solids are exist like these are the arrangement of the particles inside the solid state. This is the arrangement of the particles inside the liquid state. In the case of gaseous state, the arrangement is like this. Means when you observe in these three cases, the interparticle distance is very less. In the case of solids, it is less. In the case of liquids, it is more. In the case of gaseous state. And the next one is interparticle attractions. When you observe the next property, interparticle attractions in between solids and liquids and gases, the interparticle attraction forces between the particles is more in the solid state, because when you observe, the particles are very close. They are very close. That means the attraction force between the particles is more in the case of solids. But in the case of liquids, it is less. But in the case of gases, it is very less. The last and final property is nothing but compressibility. That means just take any solid compound and try to compress by applying some force. You cannot able to compress any type of solids. The only reason is there is no space between the particles inside the solids. Therefore, the compressibility is very less in the case of solids. But in the case of liquids, when you observe, they have some space between the particles of matter. Therefore, we can able to compress somewhat when compared to the solids. Therefore, the compressibility is somewhat less in the case of liquids, but it is more in the case of gases, because when you observe the arrangement of the particles of the gaseous particles, it is having more space in between them. Then you can able to compress more. This is about the differences between three important states of matter: solids, liquids and gases. Let us discuss about the next state of matter, plasma. Plasma. Normally, this fourth state of matter you cannot see in our surroundings. Then how it is exist and where it is exist? Normally, this plasma state of matter we can call it as super hot. It is called as super hot. Means how it is exist means, atoms. When you are able to give certain amount of energy to any atom, then it will produce some type of electrons and it form an ion. That means atoms of ions and electrons are coexist when you are giving certain amount of energy. That type of state what we can call plasma state. Usually this type of state you cannot see in our surroundings. When you observe near to the sun or stars, you can see the fourth state of matter is nothing but plasma state. Let us discuss about the fifth state of matter, Bose-Einstein condensate. Bose-Einstein condensate. What is this Bose-Einstein condensate? Actually, Bose-Einstein condensate is nothing but opposite to the plasma state. That's why it is called super cold. Then, how this Bose-Einstein condensate will exist? Let us take these atoms and you can try to cool near to the 0 degrees, near to absolute 0. Means, let us take these atoms and you try to apply nearly 170 nanokelvins. Nano means 10 power minus 9. Nano means 10 power minus 9. That means just take any atom and try to cool 170 nanokelvins. Then you can create this type of fifth state of matter and it is called as Bose-Einstein condensate. This is about 5 states of matter. Let us discuss one more important property, that is nothing but diffusion. Diffusion. What is meant by diffusion? Diffusion is nothing but the intermixing of the particles of two matter. The intermixing of particles of two matter. That means when this diffusion is possible, how it is existing solids, gaseous and liquids. Normally, diffusion is nothing but, let us take, this is solid. This is nothing but liquids. This is nothing but gaseous. Means when you observe these three different states of matter, in solids the particles are closely packed. That means the diffusion is very less in solid state because there is no space between the particles for moving. There is no moving means there is no diffusion. That is why diffusion is very less in solid state. But when you observe in liquid state, there is some spaces between the particles. Therefore, diffusion can able to take place in liquids and you can see diffusion more in gaseous state because there are more spaces in between the particles. And moreover, this diffusion increases with increasing temperature. Already in the previous class, we discussed about this one. When you are increasing the temperature, then the kinetic energy of the particles increases. Therefore, diffusion also increases. Let us discuss about the next one is nothing but measuring scales of temperature. Measuring scale of temperature. Usually, we have three different types of scales to calculate the temperature. Those are degree Celsius, the second one Fahrenheit, and the third one Kelvin or absolute temperature. Degree Celsius, that is nothing but, you can use like this, degrees Fahrenheit and degrees Kelvin. That means we can calculate the temperature in three different scales. Those are degrees Celsius, Fahrenheit and Kelvin square. Let us take the freezing point of water is freezing point of 0 degrees Celsius. That you can calculate in Fahrenheit also. By using the relation degrees Fahrenheit is equal to 9 by 5 into degrees Celsius plus 32. By using this, we can convert the degrees Celsius into Fahrenheit. And at the same time, by using degrees Celsius, we can use another scale to calculate the temperature, that is Kelvin square. In this Kelvin square, we can calculate degrees Kelvin square is equal to 273 plus degrees Celsius, means freezing point of water is equal to 273 plus 0 degrees, nothing but 273 Kelvin. Thank you.